Hi, welcome back to Drafting 112 with at Blue Mountain Community College. Today we're going to start going through Chapter 2 in our textbook, and Chapter 2 is all about geometric construction. Now, geometric construction really means taking our basic geometric shapes, mostly circles and lines and rectangles and squares, all those basic geometric components, and we combine those together in order to make the different parts that we draw as drafters. Historically, those constructions were done with manual drafting techniques. So let's go through our PowerPoint presentation and our textbook, and we will talk about a little bit about how we make these pieces and parts and shapes historically and how we do them with modern methods. So we're also going to talk about something called the WCS, and WCS stands for World Coordinate System, and this is kind of how we need to understand the World Coordinate System so that we can understand how AutoCAD stores our drawings so that we can make sure that we get the performance we're expecting as we move through this course. So in your textbook, there's also a discussion about using a startup dialog box, and that's really a way that you can control how AutoCAD behaves when you first launch the program, as well as there's also a description for how to set up your grid and snap intervals, and I'm going to leave those to you because what I want to take our time with during this conversation is actually creating a drawing of a part, and in doing that, we're going to use these geometric constructions. So we're going to kind of fly through this presentation, and then we'll get into AutoCAD. In order to understand why we need to know how to do geometric construction or understand these techniques, we kind of need to take apart our drawings and understand some of the implied geometric relations that exist. So, for example, let's take a look at this plate right here. There are a lot of implied relationships between these parts that we will use to draw this piece. So we've got this curve back here that's part of a circle, and we've got these curves here that are also parts of circles, and that's joined to this part of a circle out here on the front end. Now, there's some implications here. It's implied that if we were to draw this entire circle on the back end and these two circles here, they would share the same center. That means they're concentric. It's also implied that all of these internal circles, their centers lie on the same horizontal line. There's an implication that the edges are perpendicular, that's what this little T symbol means, perpendicular to a vertical line drawn through the center of any of these circles. There's an implication that this straight edge is tangent to the circle that makes up the end, and that the top and bottom edges are parallel. Now, this line is not tangent to this curve on this cutout. However, this horizontal line along the narrower edge is tangent to this cutout curve. And again, these two vertical lines are horizontal, and these circles in the front are concentric. So the curve that makes up this front edge and this circle that makes up the interior share a center. So when you look at a part that you're trying to create, you want to think in terms of basic geometric shapes that you're going to use to make up these curves. So for example, instead of drawing an arc to make this, that was one way to do it. Another way to make this shape back here is to draw a circle and then trim off the parts we don't need. We'll talk some more about that as we go through this class. One thing you'll find is that there are multiple ways to do anything. Now, historically, these parts were also created by drawing these basic geometric shapes, but they were drawn by hand using manual drafting tools. And your textbook walks you through, starting on page 4 of chapter 2, kind of walks you through some of these manual techniques. But if you've never used a compass and straight edge before, their walkthrough is a little bit sketchy, a little slim on details. So I've created a video of demonstrating some of these manual techniques. I didn't do all of them. I only did some of them. But you'll find it on our YouTube playlist for this class. And it will also be embedded in the eCompanion shell for this class in the week 1, right below this video, actually. So I encourage you to get a compass, and you can buy a compass and protractor set for relatively little money. These two came together. I purchased them for a whole $3.49 in the school supply aisle. So, and this compass and protractor will work just fine to demonstrate these techniques. You do, if you do want to get one of these, so you see this screw piece here, it's important that you have a screw setting on your compass and not just a slider. The slidey ones slip and don't hold the same radius or diameter, radius setting. So, and you'll notice as I'm doing these, demonstrating these, that although this has got angle measurements on it, I don't know if you can see those, I don't use it to measure angles when I'm doing things like transferring an angle. I use the construction techniques because the construction techniques are going to be more precise. So I'm going to just kind of skip through all of these. I do encourage you to pick up a compass and straight edge and attempt these techniques because we use similar methods sometimes in AutoCAD, and so it will be advantageous for you to be familiar with the manual techniques. And sometimes, if you're just trying to create a drawing and you don't have AutoCAD available, or say you're not at your desk with your computer, but you happen to have a compass and a straight edge, it's handy to know how to do these things. So we can bisect a line or an arc. We can bisect an angle, and bisect means to cut in half. We can transfer an angle from one place on a drawing to another. So what that means is we've got this angle BAC here, and we need to make this exact same angle relative to XYZ. And there's a couple different ways we can do that in AutoCAD. You can also do it manually. Dividing a line into an equal number of parts. The most precise way to do this is not to measure the line AB and then divide that number by 5 and make that many divisions. The most precise way to do that is with this technique here, where you draw a line that is 5 inches long at an arbitrary angle, subdivide it into 5 1-inch increments, and then what you do is you connect the end of that line to the end of the line you're trying to subdivide, and then make lines parallel, and then your subsequent divisions in your baseline will be equal. Now remember that in manual drawing you had different line weights. So this line AB would be a dark, possibly pen line, and these construction lines, so all these lines that we draw in these intermediate sketches, would be light pencil, and then manually they would be erased before the final drawing was produced. It was not a quick process to draw by hand. We could also draw a circle through 3 points. This is another technique that requires a significant amount of precision, but does work. Equally, we can draw a circle of a certain radius that is tangent to two different lines, like this one. So an example of this would be if we had a part that had a circular end and the sides went off at these two angles. That end piece would be tangent to those two lines, and we'd need to be of a certain radius. You can also have circles that are tangent to a line in an arc. So we've got, and so maybe we have a part that has this curving in shape, and then it's got like an S-curve. So we need to draw a circle that is tangent to this upper arc and to this bottom line. Occasionally we have to have circles that are tangent to two different arcs. There are techniques to do that as well. Now we're into AutoCAD. And we talked a little bit in Chapter 1 about different input techniques. One technique that you can use in AutoCAD is called dynamic input. And what that means is if you notice, so I'm just going to draw a line here. I've switched over to AutoCAD. And once I click on the line command, my cursor then has got information right next to it. That's part of our dynamic input. So I can either specify the first point, or I can actually type the coordinates of one endpoint of my line. So let's say I want this line to begin at the origin. I can just type 0 and then comma and then 0. And if I hit enter, my line now is beginning at the origin. And I'm just zooming in so that, okay, now you notice that as I move the endpoint of my line around, there are different, like the information at the end of the line near the cursor changes. Now, the line command will always default to what's called polar input, which means that what we're doing is we're specifying a length and a radius, and an angle from horizontal. So what I have right now is a line. If I were to click, I would have a line of 0.6514 inches in length and 19 degrees, at an angle of 19 degrees from horizontal. Actually, I'm in metric, so that's going to be 0.5614 millimeters. It's a little bit short line. But let's say that I don't really want polar coordinates. I want the end of my line to be at the 0.34. What I can do is I can just type 3, comma, and the minute I put in that comma, AutoCAD knows that I want to use rectangular coordinates, and I can hit enter. Now, I don't want to click, because if I click, it's going to click where my mouse is. So I can just hit the enter key, and then we'll hit space to end the line command. And, sorry, zoom to extents, and there is my line. And right in this, so if I click on the line command to activate my tooltip, you can see that that endpoint is at the 0.34, and I started at the 0.00. All right. So dynamic input is what I just did. I just typed at the tooltip. It is not intended to replace the command line, but it keeps my attention near the cursor, so I'm not looking up and down. All right. The other thing you want to do is turn on Object Snap. So to do that, you go into your tools, your toolbars, AutoCAD, Object Snap, and turn it on. What that will do is open up this little toolbar that's right here. Now, it might be hard to find because it might not appear there. In fact, if you have two monitors, it may appear on the opposite monitor from where your AutoCAD screen is, so be sure and look around for it. The other thing I have up here is my calculator. This is a quick calc. Your textbook talks about utilizing quick calc. you'll notice, so I'm dragging it around. You can drag things around within AutoCAD by clicking on this bar right here. And I can make it snap to that sidebar right there, or I can actually pull it back out and make it float. Sometimes it's a little finicky to make it float. There it is. So you click on the top bar. What I want to do is I'm just going to close it. I don't really want it open right now, so I'm just going to close it out. Okay. Be sure and play around with these. Hover over these symbols on this toolbar right here so that you know what they mean. So I can snap tangent. I can snap to a center. I can snap to an endpoint. I can snap to perpendicular. Your textbook has got some activities to play around with these. I highly recommend you do them so that you are familiar with how snap works. And these begin. So this activity to play around with your snaps actually begins on page 13. This particular slide about bisecting of line or arc begins on page 19 of chapter 2. So do use your textbook. Open up your textbook and go through the AutoCAD activity that starts on page 13. This is how you will gain confidence in operating AutoCAD. And these activities will go through all of the manual, the AutoCAD equivalent of the geometric construction techniques that we talked about earlier. So these are things you'll have to do eventually as a draftsman. I do encourage you to practice them and as a fundamental, make sure you know how to do these things. All right, I am going to jump all the way to creating this rocker arm design. Now, what I'm going to do actually is I want to keep this image on my screen. So I'm going to snip it using my Snip Tool. If you have not found Snippet, it's convenient and handy. It comes with any Windows machine, so you all have access to it. Now, I'm going to go ahead and empty this, or end this presentation, so that we can talk about this shape. What we've got here is we've got this rocker arm design. The way we're going to build this is we're going to start by building the outer shell, and so the outer edge. We're going to build the outer shape, and then we'll put the geometric, the keyholes inside. We'll put the square and the hexagon and the circle inside. Now, if we look carefully at this outer shape, we can see we've got a curve with radius 25 on the lower end. That is tangent to another curve with radius 40, which is in turn tangent to another curve of radius 50, which is in turn tangent to yet another curve of radius 50, which is tangent to another curve of radius 25. There's a line segment that is tangent to that curve and another curve of radius 50. And that radius 50 curve is connected to our first curve by yet another line that is tangent to both the radius 50 curve and my initial curve of radius 25. Okay, so the other thing we want to notice is my dimensions are all given from the center point. So if we look, I've got these dimensioning lines that start here in the center, right here. And I'm told that my center of my square is 70 units to the east or right and 40 units up from my center point. The other thing that I didn't mention is that it's implied that this end curve is concentric with that keyhole. and that this circle here is concentric with this inner circle and is in fact centered at this point that is 60 millimeters down from my center point and 50 millimeters to the left of my center point. Now in your textbook, this rocker plate is pictured on page 34. So you can keep it next to you to look at, keep the picture next to you to look at as we create this. And there are multiple ways to do this. I'm going to demonstrate one way. You may use a different way. That's all right. There are, as in most things technical, multiple ways to go about creating the same image. And as long as we all end up with the correct image, how we get there isn't necessarily as important, other than a few things. You want your origin to be in the space that you want, that is appropriate. Because if we were to, say, put this image as a block into another image, your origin is what you're going to place. The origin you create with this drawing is how you would place that object in your new drawing. So you want to be cognizant of the decision-making process that you utilize for defining your origin. All right, I'm just going to take out some of my marks here. And we are going to go ahead and get started. So if you haven't already opened up AutoCAD, go ahead and do that. Now this activity begins with, on page 35, with a discussion of setting up your AutoCAD interface for this drawing. The one thing you want to make sure you are doing is you want to make sure you are in millimeters. So let's just check that real quick. Let's go to Format, Units, make sure we're in millimeters, and let's go ahead and set our decimals, our decimal precision to 0. Say OK. We might want to go ahead and check our grid snap, make sure it's turned on. It'll be convenient to have your spacing set at 10 and 10. And we can display our drawing grid if you would like to. Now what I'm going to do, so let me see, view. Make sure your UCS icon is turned on. So the difference between UCS and WCS. UCS is your user coordinate system. It's like the local coordinate system. WCS is the world or universal, the world coordinate system, and it's always in 3 dimensions. We're only working in 2 dimensions, so we are only going to care about an X and a Y. That's why we have our our user coordinate system set so that the origin displays. We like to display the origin. It's nice to know where it is. Okay, I am going to erase my line that I was drawing with a minute ago, and I'm going to go ahead and change my zoom just a little bit, move my origin up into the middle of my screen. There we go. Okay. So now we're going to go ahead and get started. And the first thing I'm going to do is I'm going to draw that center circle that will make up both of those arcs. So what we're going to do is we're going to make these 2 arcs, this guy and this guy, as parts of the same circle centered at the origin. And then we're going to place the circle that makes up this arc and the circle that makes up this arc. Sorry for the sloppiness. It's hard to draw with my mouse. But it'll be better in a minute when I do it in AutoCAD. And then we'll go from there to put this together. So the first thing we're going to do is place those 3 component circles. All right. So what I want is a circle. And you'll notice we've got multiple choices here. What I'm going to do is I'm going to choose the center radius. And I want that circle to be centered at the origin. So the first thing my AutoCAD asks for is specify the center point of the circle. I want my circle to be at 0, 0. I've got a couple of options. I could come down here and click on the center on the origin, or I could type in 0, 0 and hit enter. And that puts my center at the origin. Now the next thing I want is a radius of 50. And again, we've got a couple of options. We set up our grid so that each dot is 10. So we could go to the 5th dot and click. Or we could type in 50. Either way, just make sure you put in a circle that is centered at the origin and has a radius of exactly 50 millimeters. Now we'll do the top circle, and we can right click. So I clicked my right mouse button and say repeat circle. So I want another circle, so we'll just repeat circle. I want this one to be centered at 70 40 with a radius of 25. And I'm going to do that one more time. I'm going to repeat circle. And I'm going to center this one at, now this time I'm on the negative side, so it's going to be negative 60. Sorry, that's not right. It's going to be negative 50, and I'm using comma, negative 60. And I'm going to hit enter with a radius of 25 and hit enter. All right, your drawing should look something like this. And it is as pictured on page 39 in your text. I just want to check my center point on this circle real quick. $70.40, yes, that one is correct. All right, and I can escape out of that command now. Okay, so now what we're going to do, so we've created the circles that form the basis for our end pieces. Now we're going to draw in these two lines that are tangent to both of those circles. If you haven't already, go turn on your Object Snap toolbar, and you'll find that in Tools, Toolbars, AutoCAD, and about midway down you'll see Object Snap. We don't keep all of these toolbars turned on because there are a lot of them and our screen would get very congested. So we just turn on the toolbars we want. Right now we want Object Snap turned on. Okay. Always escape will get you out. So what we're going to do, first thing we're going to do is we're going to tell AutoCAD what we're going to draw. We're going to draw a line. And AutoCAD says, give me the first point. Well, my first point is going to be tangent to this circle. So I want to turn on my object. I want to click on Snap to Tangent. And I can just click somewhere on the upper left-hand side of that circle and hit enter. And now to place my other endpoint, I will again click Snap to Tangent and click enter. Hold on. Snap to Tangent. Give me a line. Snap to Tangent. Click. And now again, Snap to Tangent and click and hit a space to end the command. What AutoCAD just did was create a line that is tangent to both of those circles. Let's do that again and create the other line. So we'll first tell AutoCAD we're going to draw a line. We will snap to tangent. Click somewhere on the big circle. Again, click snap to tangent and click somewhere on the smaller circle. And AutoCAD creates the line. There's only one line that will be tangent to both of those circles. Okay. Your drawing should now look something like this. Now, what we're going to do, pull this back over, is create these inner arcs, these lower arcs. That guy, that is a radius 50, and this guy, that is a radius 40. Now, both of those circles, so let's talk about this one first. This one is tangent to this upper curve, this upper circle, and tangent to this lower circle, and has a radius 50. So we are going to use, remember there's a manual construction technique to construct this type of circle that's kind of tedious and takes a while. AutoCAD also can draw what's called a TTR, tangent radius circle, which means that you're creating a circle that is tangent to two other things. Those things can be lines or curves, and has a specified radius. So we're going to draw a TTR circle. Now, our tooltip says first specify some point on the object for the first tangent of the circle. What that means is click on one of the objects that this circle needs to be tangent to. And we are going to click on this upper circle. Okay. And then it says click on the other object to which the circle must be tangent. We're going to click on this big middle circle. And then it says specify the radius. And my radius is 50. And if you hit enter, then AutoCAD puts in the circle. Now this may look a little weird because it's a whole circle. But if you look, this part of that circle right in here is tangent to both of those other curves and creates that inner curve of our part. So we're going to do that again with the lower one, with this lower curve. This guy here, we're going to create him by drawing a circle that is tangent to this lower circle of radius 25 and tangent to this big central circle and has a radius of 40. So let's repeat our TTR circle. Specify a point. Sorry, that's not a TTR circle. We want a tangent radius. Specify a point on the first tangent, this guy. Specify a point on the second one, second tangent shape, this guy. And now specify a radius, and my radius is 40 millimeters. Okay, believe it or not, we're getting there. We actually have our outer edge built. All we have to do now is erase the extra stuff. And the cool thing is that AutoCAD can erase the extra stuff for us very easily. So we know there are some things here we want to erase and some things we don't. What we're going to do is we're going to use this trim command. Trim command does exactly what it sounds like. It trims a shape based on cutting edges. So the first thing we're going to do is we click on trim. Now, when we use trim, we specify our cutting edges first. So, for example, this upper circle, we want to erase just the inner part. So this line will form one cutting edge. This line will form, this circle will form another cutting edge. Once you've selected your two cutting edges, you need to right-click with your mouse. And now you can select what we're going to cut, which is the inner part of this circle, with a left click. So let's do this again. I'm going to hit spacebar to end the command. And now we're going to repeat trim. So I right-clicked I clicked on my right mouse button to bring up this menu. We're going to repeat trim. We're going to now trim the outer part of this circle. So my cutting edges are this outer edge here and my big central circle here. So those are my cutting edges. Now right-click and select what we're going to trim. And then, so I'm hovering on the part of that circle that I want to go away, and I'm now going to left-click and spacebar to end the command. We're going to repeat trim. Let's trim this guy here. So select one cutting edge, select the other cutting edge, right-click to tell AutoCAD we're done with that part, and select what we want to go away, and spacebar to end. Now, we're going to repeat trim. I'm going to trim this guy here, so select one cutting edge, select the other cutting edge, right-click to proceed, select what we want to trim, and actually we can trim this guy too because those are the same cutting edges, so we'll just trim him too. Spacebar, one more time, this cutting edge, right-click, and trim. Spacebar to end. You can see that we now have the basic outer shape of our rocker arm. Now all we need to do is put in the inner keep holes. And let's start with the middle one. All right. Let me erase some of my markings here. Clean up my drawing a little bit. Okay, so what I'm going to do is I want to put this middle polygon guy in, and we will do that. That is a hexagon, but it is also a polygon, and we will do that with the polygon command in AutoCAD, which is this guy right here that right now looks like a rectangle, but if we click on the little down arrow instead of on the rectangle, we get polygon. And first thing we have to do is tell AutoCAD what type of polygon we want to draw. In this case, we want to draw a 6-sided polygon. And once you've entered that number, hit enter. Now it says specify the center point. Well, I want this thing to center at the origin, so I'm going to come down here. And because I turned on grid snaps, it snaps to the origin. I'm going to click enter. Now, the next thing we have to do is choose whether we want this polygon inscribed inside of a circle or circumscribed about a circle. To understand the difference, inscribed inside a circle means that your corner points touch the circle. What that means is if you've got corner-to-corner dimensioning, you will specify that corner-to-corner dimension. However, if you've got side-to-side dimensioning, like we have here, then you want to draw your polygon on the outside of the circle. That means circumscribed about the circle. So the sides will be touching the circle. And we will choose then so circumscribed about the circle. Now, notice that as I move my mouse around, it changes the orientation of my shape. I want to be a little cautious to make this shape match my drawing. So I want my mouse to be out at an angle 45 degrees from my origin. And now I can specify my radius. Again, we got to be a little careful. My drawing says that my center keyhole is 60 millimeters side to side. That means it's got a radius of 30 millimeters, or rather that it is circumscribed. It is drawn around a circle of radius 30 millimeters. So we'll type in 30 and hit enter. And AutoCAD put in my center keyhole for me. Now we'll put in a square. So we'll put in that upper square. We will right click to repeat polygon. This time we want a square, so we're going to put in a 4-sided polygon. And we want to center, we want this thing to be concentric with this upper circle. So what we're going to do is we're going to go over here to our Object Snap toolbar, and we're going to snap to center. We're going to snap to the center of this circle, so that one right there. We can click, and we again have got a side-to-side dimension, so we're going to circumscribe this about a circle. And our radius is 10 because our total dimension side-to-side is 20. So this will be 10. And there is our upper square keyhole. And now we just need to put in a circle. Now, though we got a center point and a radius, so we'll choose, actually we've got a center point and a diameter. We can choose either one. Let's use the center diameter circle. And we're going to again snap to center. We're going to snap to the center of this lower circle, which shows up right there. And our drawing tells us that we have a diameter of 20 millimeters, and hit enter. And there we go. We have created our keyhole. Go ahead and save this guy somewhere. I'm going to save him, so go File, Save As. And I have a subfolder here. And this is the Chapter 2 rocker arm. And hit enter to save it. All right, that's how we do that. Now, your textbooks got a discussion about using that Quick Calc utility to measure distance. I will leave that for you to play around with. And your assignment for this chapter is to complete the 5 drawings that begin on page 55. I want you to do all 5 of those and submit them to the Dropbox. And I will see you all again soon.